Okay, so welcome. So this is going to be a list. So this is part 2, B. So we're going to be looking at list. So list is a type of data set, right? So in Python, anytime we say list, so we just want to have many items, and we want to be able to call them, we want to be able to work on them, and all of that. So for a list, let's say for instance, use 1, 2, 3 as items in your list. Let's say I have 1, 2, 3, 4, 5, 6, 7, right? Now, don't forget that for a list, it's going to be a square bracket. If you're using curly braces, if you're using your normal bracket, that's not a list. For a list, it should be a square bracket. So you should always use a square bracket for a list. So if I run this and I say it's going to bring out this for me. Let's say I call this list A. So this is A, for instance. So that's to say that anytime let me add a new cell below. So anytime I say A and I call A, it's going to bring out these items, right? Let's take, for instance, we have what we call a nested list. So this is just a list. So we can say this is a list. Now, this is what you call a nested list. So a nested list is a list that have a list inside another list. So you call it a nested list. So this is what? So this is a nested list. So imagine I have items, a string, an integer, then a list. So let me still have another list. Let me have everything here, right? If I run this, you're going to see that I have I have 1, I have 1, 2, comma, I have 1, 2, 3, 4, 5, 6. Now, one thing with the list is, let me delete this. One thing with the list is that you can One thing with a list is that, like I said, you're going to call the items from a list by saying 0. You start from 0. It's just like what's it called? A graph. So a graph is going to be with X and Y coordinates or axes. Let me keep it simple. Now, what you're going to find out is that in this graph, your graphs will always start from 0. So index we start from 0. Then we say 0, 1, 2, 3, 4, 5 that way. Or we say 0, 1, 2 for the y-axis, then minus for the negative y-axis, then negative for the negative x-axis. So the point I'm trying to make is that we always start from 0. We say 0, 1, 2, 3 that way. Now, so when we are also from our index, once we're also counting for a list, we start from saying what? 0, 1, 2, 3. Everything here is 3. So the point is that if I declare this as B, for instance, right? And I call B, I'm going to get all of this. The idea now is if I say B, square bracket, 0, the answer is going to be what? The answer is going to be high. Right? If I say B0, the answer is going to be what? The answer is going to be high, because high is the first item in my list. If I want to call this particular one here, it's going to be 1. If I want to call 1 and 2, it's going to be 2. What about if I want to call this particular 2 here. So it's going to be 2, which is this guy. Then I'll open another square bracket. And I'm not going to say 0, 1. So I'll say 1. You see, I've picked out 2. So at times when you have a list, you might want to pick out items from your list. So this is how you actually go about doing that. So just understand that you're going to count from 0, right? And also you're going to do what? You're going to be able to pick items even from a nested list. Okay, now let's look at something else. Okay, I think this is about all of it. A target, so you could pick items from a list. So that's about a list. So you could pick items deep down into a list. Let's say we have a list in a list. So you can also use that same approach to pick items from the lists. So let's look at dictionaries. So dictionaries are very important. So, in a dictionary, let's declare this dictionary. So the difference between a list and a dictionary is that a dictionary is going to be key pairs. That's one way we know it's a dictionary. So a dictionary with key pairs. So that's what makes it a dictionary, because you see your normal dictionary, you say photosynthesis, you have the meaning. You say world, you have a meaning. You say land, you have a meaning. You say laptop, you have a meaning. You say biro or pen, you have a meaning. You say water, you have a meaning. You say sea, you have a meaning. Words and meaning. That's why it's called a dictionary. Anytime a data type have to have pairs, you call it a dictionary, because I have key item 1. Something like when you want to represent data such as state and capital, it cannot just be a list of items. It's going to be key pairs, because it's going to say the state and the capital. In the US, in the UK, in Nigeria, a lot of countries, you have the states and you now have the capital of those states, or countries and their capitals. So you have something like a key, the item. So you see it's separated by a colon, comma, E, then the colon. So we classify a dictionary as key pairs. Same thing, anytime you want to call an item, you call it by the key. So if I want this second item, I'm going to say key 2. Let me do another one. So let's say I'm going to just use this template. I'm just going to say Nigeria, and I'm going to say Abuja. I'm going to say FCT. I'm going to say Abuja. That's the capital of Nigeria. Or let's say countries. Say countries. Take, for instance, countries. I'm going to say Nigeria. I'm going to say Abuja. I'm going to say Gambia, or the Gambia. I'm going to say Banjul, comma. So I'm adding more to the items. So I'm going to say I'm adding another one. I'm adding another one. Right, you see it? So it's going to be the string. It can be a string, it can be a number, it can be anything. A string, its item, a string, its item. The next one is going to be, let's say, let's say Ghana, and its capital is what? Accra. Then let's say US, and let's say Washington, D.C. or New York, Washington, D.C., if I'm correct. Then let's say Canada, for instance. Let's say Toronto, or let's say Ottawa, whatever state we have there. So we just have some countries and the states or their capitals within those countries. Now, if I run this as country, let me just use a small letter for simplicity. If I run this, I've declared a dictionary that have words and their meaning, or let me say countries and a capital or a popular state. So if I want to call out Washington, D.C., if I spelled my Washington, D.C. correctly, so I'm going to be saying countries, and I'm not going to be saying US, right? So that's how it's going to be. I close this bracket, I run it, I'm going to get Washington, D.C. If I need to call out, let's say, if I need to call out Accra, I'm just going to say Ghana. If I look for Ghana, I'm going to say Accra. So that's how you work with a dictionary. A dictionary just typically keep it. So you can practice with different samples like names and their meaning, countries and capital, first name and last name, and all of that. So that's what you call a dictionary. The next data type is going to be true. Sorry, I said true. It's going to be Boolean. So Boolean is the zeros and ones of computing. So it's a data type that most of the times you use when you do conditionals, when you're trying to check stuff. You're trying to check if a certain value is true or if a certain value is false. So if you say, let's say, let me put 2 above it. Let me say, I say 5 is equivalent to Y. There's a difference between variable assignment and you trying to do comparison check. If I say Y is equals to 5, it's different from me saying Y. So let me put a comment. So this is a variable, or this is a comparison check. Whereas this is a variable assignment, right? So if I run this particular one, it's going to return false because Y is not the same thing as 5. If I run this, okay, because this is a string, you are trying to compare a string and a number. So this is not going to work because it's not defined before now. If I declare, let's say, Y before now, and let's say Y is 4, I run that, and now try to compare 4 and 5. You see, it's going to say false. If Y is, let's say, 5, I run that, it saves it, and I come and say Y equivalent to 5, is going to say what? It's going to say true. So Boolean mostly is used when we try to do some conditional check. When we're trying to check for stuff, the output most of the times can be Boolean. Or if we say Y greater than 10, the answer is going to be false because it's not true. Y is 5, and there's no way Y is going to be greater than 5. But if I say Y is less than 10, it's going to say true, yes. If I say Y is less than equals to 10, it's still going to say what? True, because yes, actually Y is actually less or is equals to 10. So is 5 less than 10? The answer is true. So that's about Boolean. Very simple. Then tuples. So you see tuples, it's very similar to a set, but not a set. The difference is in the symbol, right? So you see, let's say a tuple, T is equals to this. The same way you call it, you call out a list, you can also call out a tuple. So you can say T equals to 0 is going to bring out the first one. If you now try to do some changes, right? And you try to say you want to assign T0, that is this one, you want to give it this. It's never going to allow that. Let's run that. It didn't allow that. Let's give it 5. It still didn't allow it. So, few things you want to take note of. You want to take note of the differences between a list, a dictionary, a set, and a tuple. So let me get a summary for you. dictionary versus set versus tuples versus lists. Now, some of them are mutable, some of them are not mutable, some of them are ordered, some of them are not ordered. So let me just explain in summary. Now, are you seeing these data types? So you have list, tuple, set, dictionary. So these are four major classes of data type in Python. For a list, understand that it's ordered. So you just have 0, 1, 2, 3, 4. So the same way it is. But for a set, for instance, it's unordered. Right? So one other thing you need to take note of is operations that you can perform on each type of the data type. So like, for instance, you see mutable. You can add to a list by doing append. That's a function. You can append to a list. But you cannot append to a tuple. That's why we're not able to add or we're not able to edit because it's not mutable. Right? Mutability. Duplicates can contain multiple instances of the same element. Take, for instance, for our list that we have, this list, for instance, you see you have one. You have one inside a list. We can go ahead and now say, okay, we want to have, comma, another one here. And it's going to be fine. See, there's one here, there's another one here. If we declare one, that is 0, 1. If we declare this first one, it's going to call out 1. If we declare this particular one, which is 0, 1, 2, 3, 4, it's also going to declare that one. So the idea is that for a list, it's mutable. You can allow duplicates, but for a tuple, it's not going to allow that. So depending on the kind of data that you have that you are dealing on, that is going to tell how you should declare that particular variable. So you have list, tuple, set, dictionary. I think you can look this up later on. Don't forget that dictionary is key value pairs. Like I said, you could add to it, you could remove, you could modify. No duplicate keys, right? You see, use curly braces, set curly braces, right? But if it's this, that means it's empty. Then for tuple, you use parentheses. Then for list, you must use square brackets. So these are some of the characteristics of a list, dictionary, tuples. Then the same thing you have with sets. Okay, let's look at comparison operator. I've talked about this before. 1 is greater than 2, you get a Boolean response. 1 less than 2, you get a Boolean response and all of that. Then let's look at logic operations or logic operators. Here, you're trying to do checks. Now, this is where you learn logic. Now, you want to know things like what is true and true, what is true and false, what is false and false, what is false and true, what is true or false, what is true or true, what is true or false. So all of those combinations, imagine if we're going to give you a loan and we are building a loan script or we are doing a machine learning model that is going to check several parameters. We'll have to do logic. Take, for instance, the script is going to check if you are above 50 years and you live in a certain country and you earn a particular amount. That means we have to do some logic. We'll say, if this is this, and this is this, and this is this. So if all the parameters have to be true, then we use ANDs. If any of them can be true and maybe the other one false, then we can do an AND and we can use an OR. I think maybe I will just record this part in a small, but you can also, But you can also study the truth table, truth table for like logic. So this is what it looks like. So the truth table is a mathematical table that shows the functional truth values of logical expression, listing all possible combinations of true or false for their variables and resulting outputs. I think, like I said, maybe I will just do a small 5 minutes video to explain the truth table so that it doesn't go into what we're discussing now. So it's a good to know, very, very important. But just a brief heads up. So when you say 1 is greater than 2, the answer is false. You now say and 2 is less than 3. The idea about this is you trying to say that both items must be true. And if that's not the case, then the answer is going to be false. It's like saying you are 5 years, I'm 5 years old. The answer is false. You say, for you to give me $1,000,000, you need to be 5 years old and you need to be in Cotonou or Niger Republic or China. You say you need to be 5 years old and you need to be in Cotonou or you need to be in China. It's going to return false because the first one is false and the second one is also false. So what's going to happen is that it's going to return false. But if you say or, if I put an or here currently, if I say or, if I use an or, and I said 1 is greater than 2 is false. Or 2 is less than 3, which is true. So it's going to return a true because one of the conditions is correct. So I'll pause here. I'll do a second part and I'm going to tidy up with elif, else statement. We're going to look at loops, while loops, range, list comprehensions, functions, lambda expression, map filter, methods, and that'll be all for the first part of the Python crash course.